Next topic is gradient descent algorithm for training a linear unit. So this is an algorithm of a gradient descent. So these are the steps to be followed while applying a gradient descent to a delta rule in order to find out the weight, that is the best weight that best fits the output. Means the predicted value must be equal to an actual value. We can get the predicted value equal to an actual value only when we assume or when we get a perfect weight or the good weight. So now this is an algorithm that is followed in order to get a good weight, that is a gradient descent algorithm. Here we can see that the input, that is an x vector, it is an input. So we know that the input can start from, that is an x0, x1 up to xn, and t is a target output of a particular training example. So the input and an output, it is represented in terms of a pair. So these are the steps of an algorithm. So initialize each wi. I can take a value from 0 to an n value. So I value, it depends upon the number of an inputs. So initialize each wi to some small random value. So we know that in a gradient descent rule, we are going to assume a random value of an weight initially. So after that, until the termination condition is met, do initialize each delta wi to 0, where delta wi, it is a step change value. We know that wi, it is equal to wi plus delta wi. So wi, it is an old value, plus delta wi, it is a step change value. Initially, for the first weight or for the first round of a prediction or for the first iteration, we must assume delta wi value must be equal to 0, and we have to consider only wi value that is also a random value. Now for each x vector comma t, that is an input vector comma an output in a training example, do input the instance x vector to the unit and compute the output. So if we take an artificial neural network diagram, so this is an input and these are w1, w2, w3 are the weights. w1, w2, w3 up to wn are the weights. So for the first iteration, we are assuming some random value of an weights depending upon the number of an inputs. So here we have w1, w2, wn. So for this we are going to assume randomly some weights. We are going to calculate x1 into w1, x2 into w2, xn into wn, and we are going to sum it together and we'll get a bias of it. So now the bias is given to an activation function to predict whether the value is 0 or 1. Suppose we are not getting an exact 0 value or exact 1 value, we are getting intermediate value, that is, suppose if I am getting 0.6. So it is not equal to 0 and it is not equal to 1 also. So at that time, I assume that the 0.6, it is not equal to 1 or not equal to 0. Means my output value, it is not correct. Means my predicted value, it is not equal to an actual value. So that's why I am going to back propagate and assume the different value of weight. How to get the different value of weight? The different value of an weight, it is nothing but the previously chosen the random value plus delta wi. The delta wi, it is a step change of the weight. So for all the weights, w1 plus delta w1, w2 plus delta w2, wn plus delta wn is done. And again the multiplication of the new value of the weight is done. Again it is summed and again we are going to get the bias, and again when it is passed to an activation function, at that time I am going to get an output value near to 0.8. So again it is not exactly equal to 1. So that's why again I am going to back propagate and again update the value of an weight. So this is a process of a gradient descent. So the same thing, it is written in an algorithm here. So that is wi, delta wi, it is equals to, so see here, for input the instance x vector to the unit and compute the output. So this is the first iteration that is being explained here. So after that, after computing an output, so for each linear unit weight wi, so we know that our output, whatever we have got here, it is not equal to an actual value, that is our predicted value, it is not equal to an actual value. That's why we have to backpropagate it, and initially the delta wi value was equal to 0. Now I have to change the delta wi value. So what is a delta wi value? So delta wi value, as per our derivation, delta wi, it is equals to delta wi plus eta t minus o into xi. So how this we have got, this we have got from the previous derivation, that is delta wi, it is equals to eta of summation t d minus od into xid. The same thing, it is being utilized here. So the new value of a delta wi, we have got it. Now this delta wi, it has been added to wi, so that we get an new value of the weight. So this is a continuous process until we get an exact output. So in order to summarize the algorithm, so to summarize a gradient descent algorithm of a linear unit, so pick an initial random value of a weight vector, any value we can choose it. Then we are going to perform the calculations, that is we are going to multiply it, we are going to summation, and then it is passed to an activation function so that we get an output. We will compare an output with an actual value, that is nothing but we are going to calculate the residual. The residual, it is nothing but an error. It is a difference between it is a difference between an actual value minus the predicted value. If the difference is more, then the error is more, then we are going to move a larger steps. If the error is less, then we are going to move the smaller steps. So that is a gradient descent algorithm. So then apply the linear unit to all training example, then compute delta wi for each weight according to equation 7. The equation 7, it is nothing but, so this derivation, it is taken as an equation 7. Now update each weight by adding delta wi, then repeat this process. Up to what we have to repeat? Up to when we get a minimum error, then a good weight, then we'll get an accurate output. That accurate output, it is same as that of an actual output. So this is a gradient descent algorithm. So it should be written in terms of steps like this.